calculus. We're going to start with the rules of differentiation. If you look at your mathematical tables which are given to you, there are 4 rules, types of rules used on your program. You don't have to learn them by heart. You will get used to using them regularly, but they're all there and you can return to them all the time. There's the standard rule of differentiation, where they say any x to the power of n, if that's the function, then f of x is nx to the n minus 1. That's the way it's written in your book. There's a thing called the product rule, where there are 2 parts together. There's the quotient rule, one over the other, and there's the chain rule, where from one function you can find the derivative, the rate of change of that function. So let's just also add that with differentiation it can be called one of 2 things. If a function is called y, it can also be called the function x, f of x. So y, sometimes you say y equals, or sometimes we say f of x equals. And the derivative of the function, the rate of change with respect to x, is sometimes called dy dx and sometimes called f dash x. I think it was Leibniz and Newton. They both came up with calculus about the same time. One chose to write it this form and the other chose to write it in the other. But you'll see it in both parts of your course. It's exactly the same thing. It's about the rate of change. Now, I'm going to start with one example, and you can do this. But we're just going to say, well, how do we look at the differentiation of 3x cubed minus 7x squared plus 7 with respect to x? And let's go back now and pull up the particular rule, the differentiation rule. We're going to do the standards ones first. So it says 3x cubed is the first part, 7x squared, 4x, and 7. It looks like this part is in the shape of x to the power of n of some type. It has a number before it, ax to the power of n. So let's just take the x cubed first. X cubed. What is the derivative of x cubed? What does the formula say? Well, the formula says, if you take the power on the top, x to the n comes down as a multiplier, and you reduce the n by 1. So, if that's the case, what would happen to x cubed? If y were equal to x cubed, what would dy dx be? We would take down the 3 as the integer, or as the number. We would leave the x as it was, and we would say 3 minus 1. So we get 3x, and 3 minus 1 is 2, and that's 3x squared. Looking at the second one then, 7x squared, we can do something for it. We're now on the second part, 7x squared. Let's take the x squared part of it. If y were equal to x squared, dy dx would be equal to, what would you think it is? 2x. The process is, same thing, take down the number, 2, put in what x was there, and 2 minus 1. 2 times x, 2 minus 1, 1, and x to the power of 1, anything to the power of 1 is itself, it's just 2x. Now, let's take this 7 for the moment as well. If when y was equal to x squared, dy dx was 2x. But if y was equal to 7x squared, what would dy dx be? 14. All the 7 is a multiplier. So we can leave it out for the moment and get the 2x for the dy dx, and then put back in the multiplier of the 7. 7 times 2 is 14x. Is that okay? So that's really all that's going on there in that one method that they talk about. And now let's go back to the question. So, do you want to write down the answer now for 3x cubed minus 7x squared plus 4x plus 7? You might call it out. What happens to the 3? It comes down, doesn't it? As a multiplier. X cubed, it would be, the 3 would come down from the, sorry, that's a bit confusing there. That's the 3 as the multiplier. Now the x cubed, what would happen to it? 3 times x squared. Is that okay? Minus the 7. What would happen to the x squared? The 2 would come down, isn't it? 2x. What happens to the 2 on the top? 2 minus 1, which is 1, plus 4. What about the x here? What's another way of writing that x? X to the power of 1, isn't it? So if we had, just take a side for a moment, if we had y was equal to x to the 1, what would dy dx be? The rule says, take down the number 1, x, 1 minus 1. So what's 1 times, what's x, what's 1 minus 1 anyway? 0. And what's x to the 0? 1. 1 times 1 is 1. dy dx is 1. If that was 4, wouldn't everything be 4 times it? Four times 1, 4. So dy dx here then would turn out to be 4 times 1. And what happens with the 7? dy dx of 7? 0. So the answer turns out to be 3 times 3x squared, which is 9x squared, is it? Minus 14 times x plus 4. Is that the differentiation? Now, before we just take that as a number, let's see if any of that makes sense. I'm going to write out the 4 parts of that. The 3x cubed, the 7x squared, and the 4x, or something like that. Well, I'll certainly do the 4x first. Well, I'll do the 7 first. 1, 2, 3, 4, 5, 6, 7. That's 7. Everywhere on that line has a y value, that's the y-axis, and that's the x-axis. Everywhere on that line, that's the line y equals 7. Is that okay? I'm also going to draw the line y equals 4x. I'll have to do a few numbers for this. Y equals 4x. Okay, well, when x is 0, y would be 4 times 0, wouldn't it? Which would be 0. If x is 1, y would be 4 times 1 would be 4. Is that okay? When x is 2, y would be 4 times 2, which would be 8. Is that okay? So if I draw that line, I get 1, 4, it's a bit steep, 2, 8, and I get a graph like this. Y equals 4x. Okay? I won't do the quadratic and the cubic just for the moment. But the rate of change says this. As I walk east, how much north do I go? Or as I walk on the horizontal, do I go up or down or flat? Am I in Dundrum going on a very slowly ramped escalator? Am I on a ladder? Am I going down? Which way is it? Is that okay? What's the rate of change? Now let's look at this, 7. The further I go east, what happens to the 7? Does it stay 7? It doesn't change, does it? There's no. 7. Well, what's the rate of change of 7? What was it yesterday? Still 7. Still 7. Any change on 7? It's still 7. So dy dx is 0. It's horizontal. The marble in the vase, if it were rolling, wouldn't it stop on it? It's not moving. Is that okay? Look at the 4x. Every time I go one step east, I have to go 4 steps north. Another step east, another 4 steps north. This is like K2 stuff, or whatever that is. Is that okay? This is a very seriously precarious ladder, isn't it? Like it's just going straight up into the attic or something like that off a sort of a vertical lift. Is that okay? What's the rate of change? Every step I go out, I have to go up 4, don't I? What's the rate of change? How does y change with x? For every step of x, I have 4 y's. So what is delta y over delta x? Well, the original y here was at 0, 0. This one is at 1, 4. And if you were talking about something like the line, you'd call this x1, y1, this one x2, y2. You'd get the slope, which we called m, and you'd find the slope was 4. Because for every step here, you've got to move up 4. That's the ladder, isn't it? So this one here of 4x would be just 4. Whereas if it was just the line y equals x, it would be a bit easier to climb. And it would tell me for every step out here, I'm only going up 1. So for 7 steps, I'm going out 7. So it's much more calm. Is that okay? Or if it was like this, it would be lower. Is that all right? If I were to do the other graph of a quadratic, I'd probably get a graph something like this for the x squared. Is that okay? And you'll find that that won't have a constant dy dx. Because sometimes the slope is negative, and sometimes it's 0, and sometimes it's positive. Is that okay? And if I were to do a cubic graph, which I don't have one here, but any cubic graph would be something like this. It'll turn twice. It'll turn once here and once here. And that's a standard cubic graph. Is that okay? And we can get that down. So in a cubic graph, if you differentiate it, it becomes a quadratic. Differentiate quadratic, it goes to a linear. Differentiate the linear, it goes to just a number. Differentiate the number, it disappears. Is that okay? So we've got a sense now of how that might work. So the example then, back to that, is very simply the 3 stays, the 3x cubed minus 7x squared is all of this. What I did in the first step was I rewrote the equation by adding in that the 4x was 4x to the 1 and that the 7 was 7x to the 0. Because x to the 0 is 1. Is that okay? Then I applied the rule. 3 became 3x squared, 3x to the 3 minus 1. 2 times 7x that, 1 times that, 1 minus 1 became 0, and 0 times anything falls out. So that's why we got a 0 there. The 4x0 became the 4, the 14, and the 9. The minus 7 stayed as minus. The plus stayed at plus. So that's example 1. Now let's look at example 2. Differentiate that one there. You might just like to see what your answer to that would be, writing it down, using the same method. you may have written down an answer. But I'm going to just show you how powerful that first equation formula trick was. Y is equal to ax to the power of n, dy dx is equal to a, the multiplier stays, n comes down, n, x to the n minus 1. The number comes down. When it was a 3, it became a 2. When it was a 2, it became a 1. When it became a 1, it was a 0, 0. That number can be anything. So for example, if somebody says y is equal to 3x to the 17.6, you'd say, we didn't do that. No, you didn't. But you did the formula. And the answer would be, what's the rule? 3. What would happen to 17.6? Wouldn't it come down? 17.6, x, the x would stay. What would happen to the 17.6 on the top? 17.6 minus 1, 16.6. Is that okay? Let's imagine that this was y is equal to x to the pi. What would the answer be? dy dx is pi times x to the pi minus 1. That's the rule. You put it in. Is that okay? Happy with that? So if it's y is equal to x to the elephant, dy dx is elephant, x to the elephant minus 1. Is that okay? If it's a complex number, if it's a circle, it's an apple pie, that's the rule. Is that okay? Actually, it's not quite as much as that. They're calling it a number. It's x to the n. But that number doesn't have to be an integer. And it doesn't have to be, it can be a real number. All of these things are there. Is that okay? So don't give it any great respect. So here we have a few numbers now where we've got x cubed, x2, and x to the minus 2. Were we told about a new rule? No. Does the same rule apply? Yeah. So how do we do it? Differentiating x cubed, it becomes 3 times x to the 3 minus 1. Leave the 2 out for the moment. What would x squared become? 2x. So 2 of them will be 2 times 2. X to the 2 minus 1, that's our 1. Now the minus 2, what do we do with it? Take it down. Minus 2 times x to the minus 2 minus 1, isn't it? That's all it is. The same logic. So we get 3x squared plus 4x minus, and the minus then, because the minus comes down, minus 2 by 3 turns out to be a minus number, so that becomes a minus there. Is that okay? Next one, differentiate 4x to the half plus 2x to the 3 halves with respect to that. So give that a go. Write down your initial thoughts on that. So using exactly the same rule, 4 is just a number. So we say leave the 4 as it was. X to the half. Half is the number on top, so that comes down half times x, half minus 1. plus 2, again that's just a multiplier, x, well the power is 3 over 2, so that becomes 3 over 2, x to the 3 over 2 minus 1. 4 times a half turns out to be 2. Half minus 1, minus a half. 2 times 3 over 2, they cancel, so you get 3. X, 3 over 2 minus 1, well, 3 halves minus 2 halves is just 1 half, and that's it. Okay? And that's it, really, in respect to the first rule. Okay? That's all of those rules done. The first rule. So I liken these pages to almost like a toolbox. You're in calculus, and you have this page of the tables, the mathematical tables on your side, and you're saying, this is the rule that I can use. So that's in your toolbox, and you keep that handy. So we've used that one. And now we see that that one doesn't always apply, or it does always apply, but sometimes it's hard to spot. And we've got the product and the quotient rule together now. So we're moving into that territory. Product rule. In this situation, you've got to differentiate this expression, but there's two parts in it, there's two brackets in it. Something by something else. Now there are many ways to solve this. You could say 1 plus 3x times 4 minus x squared. And you can say, I don't know how to do this, I've forgotten the product rule, I'm just going to multiply the thing out. Is that okay? And you could say, using what the Americans call the FOIL method, you multiply the first ones together, the outsides ones together, the insides one together, and the last ones together. So the first ones are 1 times 4, that's just 4. Then the outsides, first by the last is minus x squared. And then 3x by 4 is 12x. And then 3x by minus x squared is 3 by minus is minus 3. X by x squared is x cubed. Is that expression just a straightforward expression with no brackets? Could I differentiate it? Couldn't I? Yes. Differentiating 4? Nothing. X squared minus 2x, isn't it? 12x? 12. Minus 3x cubed, well, what about x cubed? 3x squared. So by 3, 9. By minus, minus 9x squared. So it looks like it's minus 9x squared minus 2x plus 12 is my answer. Is that okay? But we weren't asked to get it quite like that. We're going to do it using a different technique. Here it says there are two things, and I'm going to call one of them U and one of them V. I'm going to break them down. You can see it's a product. And what I do here is I say, oh, there's two things. I'm going to call one of them U, one of them V, and then I get into lockdown mode. I say, I'm now going to switch off the thinking. I'm going to go through the process. What does the process say? The process says U is this, V is this. Write those down. So I write them down here in a little box for myself. And I say U is 1 plus 3x. And V is 4 minus x squared. And with my head firmly in this space, everything else blocked out, I say, if U is 1 plus 3x, what's du dx? And I just differentiate this bit. And what's the differentiation of 1? Nothing, because it's a line, doesn't change. 3x going up at 3 at a time, isn't that right? V is 4 minus x squared. What's dv dx? Does the 4 change? No. The x squared would be 2x, and the minus. And I've written these down. And I say, great, that's really handy. So I have that box safe. I've done my mappings. I've picked up my marks. I've got my U and V. And I say, OK, what's next? Then I go to my table. And I pull out the rule for the product rule. So here, I use the product rule. dy dx is u dv dx plus v du dx. But I have down in my box here the u and the du, the v and the dv. I've everything ready to work. Is that okay? And I just then very simply, step by step, I say dy dx is u dv dx. U, what's u? 1 plus 3x. That's 1 plus 3x, that's the u part there. dv dx, what's dv dx? Oh, that's over here, that's the minus 2x. Then I've got, what about the next bit? Plus v, the v is 4 minus x squared, that's give me the v. And then du dx, look, that's a 3. So what I do there is just step by step, mind switched off, just locked mode into put in the numbers. And now I say, okay, there's the answer. Now I just have to multiply that. 1 plus 3x by minus 2x. Well, that's just multiplying everything in. 1 by minus 2x is minus 2x, that's the first. And then the second one is plus 3x by minus 2x is 3 by 2 is 6. 3 by minus 2 is minus 6. X by x is x squared. I've now got this 4 by 3 is 12. And minus x squared by 3 will be minus 3x squared. So I've mapped those down. Now, I'm going to bring anything here together that is the same shape. X's are not the same as x squareds. They're not the same as numbers, but they are the same. The two x squareds are the same. So I'm going to join those minus 6 and minus 3 together to give me the minus 9x squareds, the minus 2x, and the plus 12. Minus 9x squared, minus 2x plus 12. Exactly the same answer I would have got if I had multiplied it out. But the question may ask you to look at it from the product rule side, and it is easier at times. Is that okay? That's exactly how that's done. All product questions are exactly like that. Next example, quotient. You're asked to differentiate 3x over 2x plus 3 with respect to x. And you say, this is a bit tricky. I don't like that. So how do you do it? You look up your toolbox again and you say, is there anything here in the toolbox that works? Well, it's not like that one. And it's not like multiplication, which was done. Oh, there's one here with u over v. That might do. I'll use that one as my toolbox. Is that okay? So it's the u over v. If I were to call this thing here u, and this one v, I'd be able to use the toolbox I have. So I do write it out again, and I make u equal to 3x and v equal to that. As soon as I make that decision, I go into lockdown mode. And I said, I've made an allocation, I'm using u and I v. Just shut everything off. I'm going to put that in the box. I'm going to put this in my own space here. U is the 3x, yeah. U is 3x and v is 2x plus 3. Okay, now I better fill these ones out. U is 3x, du dx, differentiate 3x, 3. And dv dx, differentiating x would be just 1, 2x would be 2, and 3 would be nothing. So I've got that ready now. So u is 3x, v is 2x plus 3. I have my answers ready. Okay? So the next thing I do is I say, okay, I now know u, v, and these things. And what formula do I use? Is there a quotient rule formula that says if you're using u and v, where one is on top of the other as a quotient, the dy dx is v du dx minus u dv dx over v squared. It just is. That's fine. That's what they say. That's the method. Fine, I'm going to use that method. So I have to now fill in answers for all of this stuff. So it's v du dx minus u dv dx over v squared. I've transcribed it from the tables in the exam that I have. And I now also, that I've mapped out what the u and the v values are here, and du dx's and stuff. And now it's just concentrate. one at a time, and I say, okay, step by step. The v is 2x plus 3, so that's the v. Times du dx, that's 3, so that's 3 times there, because it's v times du dx. There's a minus then, that's the minus. U is 3x, so that's the 3x, and dv dx is 2. On the bottom, I've got v squared, so v is 2x plus 3, and that's to be squared. Now it's multiplication. 2x by 3 is 6x, 3 by 3 is 9, and the minus 3x by 2 is 6x. X's are the same in terms of their shape and size. They're not squared or they're not cubed, so that 6x and minus 6x can be taken one from the other. They actually cancel because they're the same coefficient beforehand, and I get 9 over this. And that's it. That's the quotient rule. Every quotient rule is like that. What you do is you say u over v, make your allocations, and write down then how you do the mapping. Save that protected space there, and work off that back to fill in the answer. And it's over. Is that okay? The last one is the chain rule. We're saying, where do we go with that? We've done the quotient, we've done the product, we've done the standard differentiation one, and here we've got a chain rule where we say, what's going on here? Well, we get the question, and we say differentiate 5 minus x squared cubed with respect to x. And you say, I haven't seen anything like this before. This is a bit messy. This is something that's messy enough, and then the whole thing is cubed. Now, if you had time, you could say 5 minus x cubed would be 5 minus x by 5 minus x, 5 minus x squared cubed by 5 minus x squared. You could multiply one by the other. And you could work out what all that was, and you could do the answer, and you'd be right. Is that okay? But what would happen if that was a 30, or a 13, or a 7 instead of a 3? Well, then that method is going to take you just too long. Is that okay? So there has to be another way. So the method, the way it works is, they say, I don't like that messy thing there, 5 minus x squared. I'm going to call that something else. And when you don't like something, you have to actually then call it something else. In this case, we're going to call that u. So we're going to say let u be equal to 5 minus x squared. What would you get then? Y would equal u cubed. And you'd say, that's a lovely equation. I can do that. But what were you asked to find? You were asked to find dy dx. You weren't asked to find dy du, were you? You were asked to find this one. Isn't that right? So you can't just say, I'd love to do that question, but I prefer to do this one. You have to get dy dx somehow. Is that okay? So how do you do that? Well, the first thing you do is you say, figure out, make it simple with the u. Y is u cubed. But once you make a substitution, you've got to say u is something. Let's sort out the box. U is, it sounds wrong in English, doesn't it? U is. But anyway, u is, the value of u is equal to 5 minus x squared. What's du dx then? Minus 2x. But the other part of this is y is u cubed. What's dy du? 3u squared. So now we have a box here that gives us the y's, the dy du's, du dx's, etc. And with the chain rule, it's really neat, but dy dx is actually given as the multiplication of two things, dy du times du dx. So you've got dy du. So dy dx is equal to dy du multiplied by du dx. It's like fractions. It's like something like this, where you've got 3 over 4 times 4 over 9. X is equal to. What would you do in this case? Would you multiply across or something like that? And you'd say, well, there's a 4 on the bottom and there's a 4 on the top. You'd cross them out. If we look at this, have we got a du on the bottom and a du on the top? We get dy dx. So it's really neat. So what we do is, using this trick, we say dy dx is dy du times du dx. But how do we get that stuff? Oh yeah, well dy du, we know, dy du is here. So that's 3u squared. And du dx is minus 2x. So now we say, we're really happy, we said you gave us a question that said y is equal to, I think the original question was it 5 minus x squared cubed or something like that? And they were asking for dy dx. And we now know that dy dx is equal to 3u squared times minus 2x. But that's not good enough. Because the first thing they're going to say is, what's this thing about u? I made it up. Well, don't make it up because I didn't ask you about u. I sorted out. But do we know what u was? Wasn't u 5 minus x squared? So now we can say, substituting back in for u, we can say it's 3 times 5 minus x squared times minus 2x. If I were to give that answer, does that answer only contain x's and numbers? That's the right answer then. It's sorted. So I used the u, fixed it, and had it all out of the way by the end. Is that okay? Almost like in chemistry, you use a catalyst, and then you take it back at the end, it's all gone. It was just to get something going. Is that okay? So what we have here is we've got 3u squared by minus 2x, but we now have to substitute back for the u, and there's our answer. And every single chain rule can be done like that. You look at something in brackets and you say, that's ugly. I'm going to substitute that with another letter, a U or a W or something like that. You sort out the stuff, you go down through the little box you have, you map it out, and you get rid of it all at the end. Is that okay? And that's the end of the rules of differentiation. There are 4 only on your course. They're the 4. The standard, the product, the quotient, and the chain. And that's that topic. You should be able to do every single question in that space on those calculations. Not always the interpretations, because that's somewhere else, but in terms of the physical calculation of the right differentiation, the right derivative, you should be able to do that for every single question on your course. Is that okay from that?